First of all, I would like to thank you all of you attending this Biochar conference, especially for all speakers who provide so wonderful talk. I really enjoyed it. Also, I want to thank you, Nancy and Kishore, for organizing this conference. Let us have a chance to sit together to discussing our study and for looking for some potential collaboration. Today, I want to introduce some our center ongoing and possible future biochar research. So the purpose, as just I mentioned, we want this conference put it all together, maybe discussing about the biochar, then looking for the future for some collaboration. Also, we want to lead this biochar the study, at least in Illinois. Okay, there are IST staffs and my colleague who involve and participate this biochar work. Without their help and their support, I couldn't do this job well, so I really appreciate it. As you know, biochar is a carbon-rich material produced from biomass. Biochar is similar to charcoal. Char activate carbon and break carbon. Sometimes biochar is confused with this carbon-rich material. Actually, biochar is designed for soil application to sequence the carbon and improve soil quality. Currently, global climate change is a major challenge for us. Reducing greenhouse gas emissions and increasing carbon sequestration are two primary mitigation strategies for climate change. Carbon sequestration is remove carbon from the atmosphere and store them in the reservoir. For example, right now the geological CO2 storage is really hard area in some big company in the United States. And our federal government spent millions and billions of dollars to pump the CO2 into the cold bath, to store the CO2 then in the depleted oil and gas reservoir, and stored in the salt bed and civil aircraft. I don't doubt this idea. I think this is a pretty good idea. I don't doubt the technique. Only my question is, if we can store the carbon in the soil, do we need to go so deep? Biochar is providing this possibility. As you know, biochar is very recalcitrant to the degradation. So biochar can store in the soil for the thousands of years. For example, just like this morning video mentioned the soil in the Amazon. Actually, biochar is not high-tech. Biochar, the work mechanism, kind of like slash burn. You know, slash burn is a traditional fertilization method. Burning can remove the vegetation and release nutrients to fertilize the soil. Once biochar is into soil, the sequenced carbon can improve soil quality. I saw the biochar kind of like a sponge. My daughter likes to watch SpongeBob. So the sponge, you know, kind of the biochar can trap the moisture, you know, holding the nutrients, attract the beneficial fungi and microbe, improve the CEC, cation exchange capacity. In our center, our research purpose is use waste biomass as a feedstock to transfer to sustainable biochar. Sustainable biochar is pyrolysis from like a crop residue, biomass crop, timber and forestry residue, and green waste. In here, I didn't include in regular people mentioned as like animal manure made the biochar because we found the charred manure is not really carbon rich material. In our pyrolysis, waste biomass can convert to the three byproducts. syngas, bio-oil, and biochar. This slide shows 3 bioproducts yields from under the different pyrolysis temperature. You can see with increasing pyrolysis temperature, the yields of syngas and the bio-oil increase. This is because we know usually biomass including cellulose, hemicellulose, and the lignin with the high pyrolysis temperature. These long-chain organic compounds can readily break down to the short-chain molecules like syngas and bio-oil. Syngas is combustible, can use as fuel. Also, syngas can be used to produce diesel through the Fischer-Tropsch processor. Bio-oil can be used as a heating fuel. Bio-oil also can be used as like a renewable feedstock for petroleum refining. So to know composed of the bio-oil, so we use the GCMS to determine the made compounds. This is a gas chromatogram of the bio-oil produced from the waste wood. We use according to their mass spectrum, we identify the made compounds. This is a gas chromatogram of the bio-oil produced from the fat DDG. Similar, we identify the main compound based on their mass spectrum. Also, my colleague, BK and John, they used a simulate distillation technique, the method, to evaluate different bio-oils produced from different processes. We found our pyrolysis bio-oil has more value for refining. That means it has potential to get more gasoline, kerosene, and diesel compared to the another bio-oils. For example, like hydrothermal bio-oil produced from algae. Let's go back to the biochar. Here is the ISTC. We made the sustainable biochar. Some biochar made from the fat DDG, some made from the corn cob, from the walnut shoots, and the wood chip, wood peel. So biochar made from waste biomass can provide 4 values: the waste reduction, energy production, soil fertilization, and the carbon sequestration. In addition to these 4 major benefits, biochar has another co-benefit to the aquatic environment. For example, biochar can absorb chemical fertilizer, such as like phosphate and ammonium ice, so prevent their leaching and runoff, and protect water quality. This slide shows absorption of phosphate and ammonium ice by biochar. Compared to commercial, the active carbon, the biochar made from this wood waste is more efficient to remove both chemical fertilizer. Also, this slide shows remove of the ammonium ion by the biochar produced under different pyrolysis temperature. We mentioned that by biochar that potential. So we find that the biochar, the surface is a negative charge. This means the biochar can strongly absorb most candide chemicals, including ammonium ion. But for the phosphate ion, we know the phosphate ion is a negative charge. So we found that their removed mechanism of a phosphate by biochar is different. It's a pretty simple process. We conducted 2 experiments to verify. First, the biochar, we first use the DI water to wash twice. Then use this biochar to absorb the phosphate. You can see the biochar use the this absorption capacity of the biochar used water, DI water washing, the significantly reduced. This is because use the DI water to wash biochar can remove some calcium ion. Also, we use do some XAD experiment. The black line is biochar. The red line is biochar after absorption phosphate I. In the red line, we can see the new peak appears after this peak is calcium phosphate. So we verify the reaction, the absorption mechanism phosphate by biochar is precipitation mechanism. So far we know the biochar can absorb the phosphate and the ammonium ice. So we propose two ideas. One is try to use the biochar. If you use biochar as soil amendment, we can reduce, chemical fertilizer application rate. So also at the same time, maintaining the same and high crop yield. Another idea is using biochar first to absorb nutrients. This from the runoff, the agricultural runoff, then to form a slowly released fertilizer, then apply it back to the field. So to realize these two ideas, we conduct a field and a greenhouse experiment. Here I will show you some our preliminary results in greenhouse and field experiment. So we found the use of biochar can improve jatropha plant growth. This is no biochar, this is two biochar use. You can see the difference. Also, we use the biochar for a soil amendment. Want to see the biochar use can increase crop yield or not. So here is the left side is the control. Right side is the biochar, no biochar, but use the regular fertilizer. Right side is no any biochar. We both biochar and fertilizer use. You can see there's some difference. Currently, we are using radish as a targeted plant to test if biochar addition in the soil can reduce chemical fertilizer use. So our idea is that because biochar can absorb the chemical fertilizer, so we just try to reduce chemical fertilizer. If you use biochar as soil amendment, so we can reduce chemical fertilizer application. So this will be benefit the environment reduce the cost. So this experiment, we still doing this field greenhouse experiment. If you're interested, after talk, we can go to the campus. It's just across the street in the greenhouse. We can take a look. Also, this year we conducted a field experiment. This research supported by Illinois Department of Agriculture. This experiment conducted in a local corn field. In April, we applied the biochar in the soil, mixture with the soil, then seeded. We planted the corn according to standard corn growing practice. So right now the corn plant is grow to the 6 to 7 feet high. I think we will harvest in the middle of the October. So the field experiment, we use the different chemical fertilizer. We want to invest it. If reduce use of chemical fertilizer in the biochar amended field, can still improve the soil quality and keep a same or high crop yield. So biochar not only strong absorbing chemical fertilizer, but also will infect pesticide feed in the environment, because we know most pesticides are hydrophobic organic compounds. Biochar have some relative, absorption capacity because it's have a relative the high surface area compared to soil. This slide shows This biochar produced from the wood chip can remove 4 pesticide from the water, especially for the hydrosulfuron methyl. After biochar ended 1 day, we cannot detect this pesticide residue in the solution. But we detect its metabolizer. So we know we find our biochar the pH is 7 to 10. So once the biochar absorbed hydrosulfuron methyl, they will take place, like a contraction reaction to degrade this hydrolysis product. So the removed mechanism of this pesticide by biochar is a basic hydrolysis processor. For another 3 pesticide, the removed mechanism is adsorption. This slide shows the removed pesticide imidacloprid by biochar produce different pyrolysis temperature. We use the high pyrolysis temperature. We can increase biochar surface, so increase the adsorption capacity. This slide shows adsorption isotherms of atrazine and simazine by the biochar. The adsorption capacity we found for this pesticide on the biochar are 10 or 100 times higher compared, than like a more common the agricultural soils and our compost. Also, we attending to use the biochar to remove some pharmaceutical and pharmaceutical care products. We want to investigate the potential use of biochar can remove these contaminants. PPCP, pharmaceutical and personal care products, PPCP, are receiving great potential attention because PPCP has frequently detected in the lake, river, and stream in the United States. This slide shows adsorption of fluorophenical by biochar, produce different waste biomass. Fluorophenical is antibiotics, most used in cattle farm, like a beef farm and dairy farm. So this slide shows, biochar can remove some strong adsorption some fluorophenical, especially from biochar. Some biochar made under high temperature. This slide shows adsorption fluorophenical by biochar produced under different pyrolysis temperature. With increased pyrolysis temperature, the biochar adsorption capacity consistent increase. This is because increase because with increased pyrolysis temperature, the biochar surface area increase. Also, we use the biochar produce the wood chip to adsorption 3 steroid hormones. This slide shows the adsorption capacity for the biochar to the 3 hormones, significantly higher than before I mentioned the antibiotics and the pesticide. This is like 10 or 100 times high. So this means this biochar have a potential to use to clean up like a hormone contaminated wastewater. So before so far I mentioned the biochar is non-modified. So next step we try to modify some biochar. So maybe activated biochar can use as a super solvent for some waste treatment use. Also, we will attempt to explore the pitfalls of the biochar. For example, how to apply the biochar in the non-tilled field, how to prevent runoff of the biochar, because the biochar is very light. Once used the field, if the big wind or a storm will run off. So future biochar research at the ISTC, we will focus on production. We will combat our bioenergy the research to produce the biochar as a valuable co-products, not only byproducts. Also, we conduct a field and greenhouse experiment, try to develop a evaluate system to evaluate, the biochar quality. Also, we will investigate, the residue and medical compound released from biochar, because biochar contains some toxic compound like a PAH. This table shows we identify 16 priority PAH. We find pH in the biochar, the level is like a ppm, but most soil, the pH level is a ppt. That means once biochar uses soil amendment, this PAH will release to the environment. So food plant maybe will uptake the pH, so into the food chain. So this one possible use the biochar amended soil will contaminate the food. Okay, before closing my talk, I'll give you a quick review. In this study, we used waste biomass to convert 3 bioproducts: syngas, bio-oil, and biochar. Syngas and bio can be used fuel. Also, bio-oil can be used as a renewable feedstock for petroleum refinings. The sustainable biochar made from the waste biomass can provide 5 valuable benefits: waste reduction, energy production, soil fertilization, carbon sequestration, and pollution prevention. Our center so far most work focused on the pollution prevention. So we find the biochar can absorb chemical fertilizer, including phosphate and ammonium ice. So this why use the biochar, use soil amendment can prevent their leaching and runoff, protect the water quality. So also we conduct a greenhouse and field experiment. We try to develop a system to assess biochar quality. Also want to invest if reduce use of chemical fertilizer. In the biochar amended field still can improve soil quality and keep zinc and high crop yield. When biochar is entered the soil, biochar can absorb and decompose the pesticide and affect their environment fate. Also, biochar have some relative absorption capacity. So there's a potential use the biochar to absorb, to remove pharmaceutical and personal care products like PPCP, these emerging contaminants. So future biochar research in the ISTC will focus on the biochar modification, production, and application to explore the potential pitfall for biochar application in the soil. For example, like a PAH issue. So finally, let's go to the field to discussing the biochar, this biochar research. This is just our field experiment. This is applied some fertilizer in the field, So we applied the three application-related fertilizer. So we want to say reduce the fertilizer use still can keep the same crop yield. Also, thank you. Yes.
With your showing that the calcium on the support on the last show was responsible for phosphate, did you add acid and try to leach the calcium?
No, I just used the DI water.
I know, but my question is, does the calcium come off with acid? If ion exchange, if it's cation exchange, then acid should leach the calcium off. I just wondered if you did that.
Oh no, we don't do this. But we analyze the calcium, calcium after leach. We just use the water leaching, just regular DI water leaching. They analyze calcium because in the biochar have some calcium can dissolve. Some calcium fixed, so it cannot dissolve. So the reaction is phosphate and calcium is calcium ion. If the fixed calcium, it cannot reaction.
So generally, like, have anyone used biochar in rice fields? Anyone tested biochar in rice fields?
I think so, somebody, but not yeah. Because for use biochar as soil amendment, I saw the crop response from negative to positive, maybe negative 50 to the, you can increase like 200 or 300%. This depends the soil, depend the biochar use, depend a lot of things. So that's why we want to try to do some greenhouse field experiment, set up some standard particle, can test different biochar. So we want to see which, we not say that which biochar is best and not which biochar is worst. Just also this depends on your situation, condition, soil condition, lot of things. But I'm not sure for the rice. I read some reference literature said some can increase on rice, but.
Yeah, the rate you had there on the char, it was between 4 and 8%, and then on the nitrogen, was that for the radishes or was that for the follow rates you were using?
The 8%, just the soil, just the greenhouse in the soil mixture with the 8%. We use the high to low, for different 2%, 4%, 8% biochar mixture with the soil. This is for radish plant. But because but we found so far, if you're interested, we can go greenhouse, take a look. If you use the high percentage, the biochar, maybe will damage hurt like plants. This is because it depends on soil pH. Because for my biochar, most like 8 to 9 the pH. If you put too much, the soil will become to the base. This depends on the soil because most of the field soil is a pH 4 or 5, so it's pretty good. But we use greenhouse experiment is kind of the soil is kind of neutral. It's kind of neutral. The pH is neutral. So that's why we try to test different application. We don't want to use very high biochar application rate. So I thought maybe best 2 or 4 is best. Mike?
I think there's a lot of good stuff for biochar, but I don't think removing phosphate is one of them. I mean, because you put the stuff in the still water and you lose your absorption capacity for phosphate. So I guess that's one. I think for removing anions or sequestering any sort of anion, it's really got a limited lifetime, so to speak, in terms of being effective.
Oh, yeah.
Because rain's going to do the same thing, right?
Yes, you're right.
It's going to leach that.
Yes, you're right. Yeah, you're right. Just like a lot of the phosphate actually is sticking in the soil, the rain off. This is kind of issue for the biochar because the biochar is really light. So once we apply the fuel, if it's big the windy, so in this area is kind of issue. So we saw that also the runoff is issue, similar like the soil runoff the phosphate. So, but the biochar at least can absorption the ammonia. So because as also the Kurt mentioned, after absorption of ammonia, so can reduce eutrophication. So this is why for greenhouse we test just ammonium nitrate. We don't test like a phosphate.